project title is Towards Information Diffusion in Mobile Social Network. The abstract is the emerging mobile social networks opening the opportunity for vital marketing. However, before fully utilize mobile social networks as a platform for vital marketing, many challenges have to be addressed. In this paper, we are addressing the problems of identifying a small number of individuals through whom the information can be diffused to the network as soon as possible, referred to as an diffusion minimization problem. Diffusion minimization under the probabilistic diffusion model can be formulated as a asymmetric case-center problem with the NP odds. And the best known approximation algorithm for asymmetric case-center problem has approximation center problem with ratio of log n and the time complexity O of n power I. The performance and the time complexity of approximation algorithms are not satisfiable in a large-scale mobile social networks. To deal with this problem, we propose a community-based algorithm and the diffusion set algorithm. The performance of the proposed algorithm is evaluated by the extensive experiment on the both synthetic networks and a real trace. The results show that the community-based algorithm has the best performance in both synthetic networks and the real trace compared to the existing algorithm. The social networks play an important role for spreading the information, ideas and the influence amongst its members. Nowadays, the social networks have been evolved to online social networks such as Facebook, Twitter and the Google Plus that like humans, computers and the internet, and the information spread in the social networks has been changed from the way of word of mouth. The emerging social networks open opportunity for digital marketing, differ from the traditional television or roadside billboard advertising campaign. The digital market take advantage of power of word of mouth to increasing the brand awareness or the product sales through the self-replicating viral processing, and it has attracted considerable attention from the mobile and the social computing research society. The maximization problem, which studies how the individual influence each other and how to maximizing the influence in the social networks. The diffusion minimization problem investigates how information spread and how to minimize the diffusion time. In data flow diagram, first of all, we have to forming a communities. For each community, we consider 20 or 30 nodes for each communities. Here we forming the two committees, then allocating the nodes and the weights for the each node in the each communities. And in the community based algorithm, here we are considering the design of information diffusion in the mobile social network. The concept of social related should be exploited. We designing a community based heuristic algorithm. The community represents the set of nodes in the network, where node inside the community have a more internal connection than the external connection. The community structure is prominent network property which provide a clear view of how the nodes are organized and how nodes are contact with each other, especially in the social. Then finding the diffusion time. In the distributed set cover algorithm, the approximation algorithm, the community-based algorithm are centralized and they require global information of the network. The pairwise expected diffusion time is required for approximation algorithm and the community structure is required for community-based algorithm. However, such information might not be available or to cost too much in some scenario. Such a mobile social network constructed from the opportunity node contacts. Then finding the diffusion set from the two communities, then finding the k node diffusion set from the overall community sets. Now we are going to run the demo. The title is Towards Information Diffusion in Mobile Social Network. First click the image. Then here we are going to creating the committees. Here we are using two committees, creating a nodes for each communities. 20 nodes for the community 1 and the 20 nodes for community 2. And the number of nodes is created for community 1 and here also the number of nodes created for community 2. Then viewing the number of nodes created in the both communities by clicking the view button. Here viewing the weights and the number of nodes. community 2 also we are viewing the number of nodes and their weights. Then we find out in the centralized node for each of the communities. Number of nodes in each community is 20, and we are find out in the centralized node. Here the centralized node is 5, and then we calculating the diffusion time for the node. Then next we find out in the centralized node for the community 2 also, and the number of nodes created for the community 2 is 20, and here the centralized node is 14, and the diffusion time is 247. And then for community 1, the node and the diffusion time, and the community 2 also the node and the diffusion time. Now we are going to merging this community 2 with the community 1, with who is having this diffusion time less. Here the diffusion time less calculator for node 14. So we are merging this community 2 node 14 into the community 1. Here the merging. Next we viewing the node is communicated. The node is where we are in. Find that the node is the node 14 is now merging with the community 1. Node 14 belongs to the community 2. Now the community 1 containing the 14, which having the less diffusion time in community 2. Then we discover in the diffusion set. The diffusion set having the 5, 14 and 5, the 5 having the highest diffusion. Next we find out in the K node from the diffusion set cover. Here the 5 is the highest node, which is transferring the messages faster than comparing to others node. Then clicking the graph, and then clicking the image. Here we are generating a graph by comparing the performance and the time complexity for proposed and the existing system. Thank you.